This video is going to take a look at a factoring strategy to bring all of our factoring tricks together into one tool belt. The key behind our strategy is really focusing on how many terms the problem has in it. Students, when we get to this point in factoring, often say that while we don't often teach factoring, it seems like when it is taught 9 million different ways. And so my goal with this video is to help you concentrate on what strategy we use to factor the problem we're looking at. First step is always look for the GCF first. Never forget that greatest common factor. Second, we look at the number of terms the problem has. If the problem has 2 terms, we're going to check if we have a difference of squares or if we have a sum and difference of cubes. Those are our shortcuts. If there's 3 terms, it might be a perfect square shortcut, or we might have to use that guess and check method, trying to make the first and last work and then checking the middle term. Then if there's 4 terms, we're going to use grouping. With grouping, on occasion, we have to change the order, but in general, grouping is how we'll solve 4-term problems. So here are 9 problems that we're being asked to factor, and I'm going to attempt to factor all 9 of them. I'm going to not focus so much on the process because we've already covered all the processes for factoring. I'm going to focus more on the why I chose this process on this problem. So with this first problem, 16x squared minus 48x plus 36, the first thing I'm going to look for is a GCF. And they're all divisible by 4. So I'll take out that GCF of 4, which leaves me with 4x squared minus 12x plus 9. Next thing I'll look at is we've got 3 terms on this guy. So my first thought is, could it be a perfect square with 3 terms? And sure enough, I can take the square root of the first and last term. So I think it's going to be a perfect square, something squared. The square root of 4x squared is 2x. I'll take the sign from the middle, and the square root of 9 is 3. Now with perfect squares, I want to make sure I check the middle term. So 2 times 3 is negative 6x, and negative 6x, which matches the 12x. So that means I have factored this guy correctly. It is 4 times 2x minus 3 squared. Second problem, 6x squared y minus 15yx plus 2x squared minus 5x. First thing we'll always look for is that greatest common factor, and they all have an x on them. So I'll factor out an x, and that leaves me with 6xy minus 15y plus 2x minus 5. Now when I look at what's left without the GCF, I see there are 4 terms. 1, 2, 3, 4 terms. And so with 4 terms, I'm going to split in half and use grouping. So keeping that GCF out front, 6xy and 15y both have 3y in common. Leaves 2x minus 5. Plus 2x minus 5 don't have anything in common, so we'll factor out a 1, leaving behind 2x minus 5. And sure enough, I've got that GCF binomial of 2x minus 5. So with the x out front, 2x minus 5, and what's left is the 3y plus 1. And we have factored by grouping. This next problem, 2x squared plus 50. First thing I'll look for is a GCF. Pull out the GCF of 2, leaves x squared plus 25. And now we have 2 terms. 2 terms with a squared might make me think of difference of squares, but I'm going to also remember that difference of squares requires a subtraction in the middle. I don't have that subtraction in the middle, so my thought is we're probably not going to be able to factor this anymore. So we'll call that our final solution. Looking at the next one, 12x cubed minus 26x squared minus 30x. I see a GCF there of 2 and an x. Leaves behind 6x squared minus 13x minus 15. From here, 3 terms. It's not a perfect square because I can't take the square root of 6 or 15. So we're going to use our guess and check method with 3 terms. My first instinct is these numbers are larger, so we probably want to use a 6x and an x to get larger numbers. 15 is 5 times 3. I can't put the 3 with the 6 because that would create a GCF. Let's try minus and plus and see if that gives us what we want. Just guessing at this point. On the outside, 6x and 3 is 18x. On the inside is negative 5x. That adds up to 13x. But we want a negative 13x. Well, we know to get a negative 13x, we probably just need to change the signs. So let's do that. So we'll do a positive 5 and a negative 3. And see if that changes the signs for us. Now on the outside, we have negative 18x. On the inside, we have 5x. And sure enough, there's the negative 13x we're looking for. We know we've got the correct solution. 24x cubed plus 3. GCF there is 3. After we pull out the GCF, we're left with 8x cubed plus 1. 2 terms. With 2 terms, we think about our factoring tricks. And when I see that third power, I'm thinking cubes. And sure enough, the cube root of 8x cubed is 2x, and the cube root of 1 is 1. Keeping the GCF out front, we've got the binomial and the trinomial. We use the 2x and the 1. Square the 2x to get 4x squared. Multiply them together to get 2x. Square the 1 to get 1. And then I think SOAP, same sign as the problem, plus, opposite sign minus, and always plus. And we have factored that cube. 4x squared minus 8x. We can pull out a GCF first of 4x. Leaves behind x minus 2. And since there's no exponents, there's really no more factoring left to do. That one just had a GCF and nothing more. Our next one is 4x to the 4th minus 12 plus 12x minus 4x squared. First thing I'll always do is pull out that GCF. Always check for the GCF. In this case, they're all divisible by 4 and no variables in common. So that leaves x to the 4th minus 3 plus 3x minus x squared. Now there's 4 terms. So we'll try and factor out. You see nothing's going to factor out of this first term. Maybe if I factored an x out, but that's going to give me 3 minus x. And that's not going to match. So our order must be a problem here. So I like to grab the second term and kick that second term to the end. So x to the 4th plus 3x minus x squared minus 3. That just looks like it's going to behave better. We'll see if it actually does. 4 terms, new order, split down the middle. We can take an x out, leaves behind x squared plus 3. On the right side, we always take the sign out, and 1's the common factor, leaves behind x squared plus 3, because we're factoring out a negative. And sure enough, that binomial GCF matches. So the overall GCF in front of 4, then the x squared plus 3, and finally the x minus 1. Factoring by grouping with an order change. Next, we have 81xy squared minus 25x. First thing we'll always look for is a GCF. They have a GCF of x. Leaves behind 81y squared minus 25. And now, because there's 2 terms, I'm thinking about my factoring tricks. I do have the minus that I want in the middle, so we have a difference of squareds. Notice that's different than the example in the top right, which had a plus. That plus was preventative, but with a minus, we can factor with the square roots of 9y and 5 with a sum and a difference. 9y plus 5, 9y minus 5. Keep that GCF of x out front, and now it's factored. Last one, 125a to the 4th b minus 64ab to the 4th. 125 and 64 don't have anything in common, but we do have an a and a b in common on both. Leaves behind 125a cubed minus 64b cubed. And now we have 2 terms left. So with 2 terms, we're thinking about our shortcuts. And when I see those cubes, I'm thinking about my cube shortcut. And sure enough, 5a cubed is that 125a cubed. And 4b cubed is that 64b cubed. So we'll keep the GCF of ab out front. Then there's the binomial and the trinomial. The binomial is made up of that 5a and 4b we just found. Square the first, 25a squared. Multiply them together, 20ab. And square the last, 16b squared. And then I'll use SOAP to fill in my signs. Same sign as the problem, minus. Opposite sign of the problem, plus. Always positive. And now we have factored that last one. Each one of these 9 problems used a different factoring trick, but we used this overall factoring strategy to help us organize what to do to get there. Always the GCF first, and there's not always a GCF. In fact, most of the time there's not, which is probably why we forget it most of the time. If there's 2 terms, we check our tricks. Difference of squares, sum and difference of cubes. If there's 3 terms, it's either a perfect square or we'll use our guess and check. And if there's 4 terms, we'll use our grouping strategies, maybe changing the orders. That's the strategy we'll use to attack our factoring problems. Take a look at the homework assignment. See if you can bring it all together. Ask your instructor if you have any questions, and good luck on the assignment.